Thanks for tuning back into BP Builds. This is the part 2 of the Crown Vic Supercharged project. It's been about 2 weeks since I made the first video, and I just have been thinking and kind of planning and coming up with some ideas, and I figured I would maybe just share with you where I'm at and what my next steps are going to be. So I'm not sure if we talked about this last time or not, but just like that guy Make Cool Stuff says in his video, the intake manifold on the Crown Vic is plastic, and I'm not worried about the plastic holding the pressure. I'm not worried about it holding boost, but what I am worried about is that I'm going to be mounting a significantly heavy supercharger onto it, as well as tugging on it with the belt, and there's just no way that a plastic manifold will be able to hold up to that, and it would crack. So I wanted to find an aluminum one, and I just kind of got lucky and stumbled upon this guy. Now, I was looking at the Edelbrock one. They have a non-fuel injected one that is meant for a carburetor, and they have a fuel injected one that has the fuel injector holes, but they're pushing close to $500, and I was just kind of looking around on eBay and just browsing around the internet, and I stumbled upon this, and all the eBay ad said was 1993 4.6 intake manifold, and it was just one picture, and I was like, huh, what is that thing? And I was like, it looks like it could possibly give me some ideas, and for $10 I figured, well, crap, let me bid on it. And it turns out that this is off of a 1993 Crown Vic with the 4.6, so I believe that this has the non-PI heads. Mine does have the PI heads, the performance improved, but I'm pretty sure this will bolt on, and if it doesn't, I think that there's adapter plates available. Now, what I wanted to do was find a way to adapt this face to this face, and because the intake port on the Edelbrock is fairly small, and I mean, granted, it only needs to be this big, but I'm just trying to think of a maybe a little bit cleaner way, or a little bit more sturdy way, plus a cheaper way. You know, I don't want to go out spending a ton of money, so I just figured I would maybe just explore this option first. And the way it works on the 95 is, here's where your alternator would go, and then the intake has an elbow that goes up with your throttle body here. But on the 2000, the 2010, in my car, it has the intake here, and there's an elbow with your mass airflow sensor and airbox. So my plan is, I really don't need this, and I definitely don't need this lower plenum, because as you can see, air will come in there around the bottom and then up into each runner. Now, since I'm going to be mounting the supercharger on top, there's really no point in having those there, because I'm just going to be boosting down into this thing, and that's kind of really not going to do anything. So my plan is to chop that off. You can see there's a casting line here. I just want to cut all this off, and then I'll have, 8 ports. So I'll have to take, 8 little discs of aluminum and TIG weld all those closed. Okay, and then what I'll do, and since this is part of the plenum, this area will be gone. So I'll basically just be left, from here forward, right? So, and then what I'm going to do is, we can count 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 8 cylinders, and then here's your cooling crossover. So really, all I want to do is, once I mill those off, and I'll have a nice flat surface, or I can put some spacer blocks under here. I know this is a true flat surface. I can machine just a gigantic rectangle right into this thing, okay? And then I'll have open access to every intake runner. I don't want to go into the cooling port, but I do want to get access to every runner. So once I get that opened up with a mill, then I'm going to weld in about a 1/2-inch aluminum plate, just a flat plate, and then I'm gonna tap it, probably helicoil it, and get our mounting holes. And then that will have a square in it for this port, and then also this is the bypass valve. So that's kind of my plan. It's going to be a lot of machining and some welding, but It probably would only take a weekend or two to get that done. So I figured, you know, for $10 plus $17 shipping, I mean, crap, let me at least pursue this. You know, for $30 and a little bit of a time, I might be able to get this done cheap. Plus, it'll be lower profile. You know, it'll sit lower, and maybe I'll even be able to use my factory hood with no modifications, and the car will be a real sleeper. So now that we've kind of gone over the plan, let's go to the plan on the Supercharger real quick. All right, so now I just want to go over what I'm going to be doing to the Supercharger itself. So I need to disassemble it because I need to remove this back end just for added clearance, you know, so I don't want to hit the firewall. Now, this is the bypass valve, and I want to keep this because I'm thinking that the reason this is here is because when your engine is under operating conditions that aren't requiring boost, that aren't requiring the supercharger. So let's say like a low load situation, like idle, or like just cruising down a 45-mile-an-hour road, or cruising down the highway at 65, 70 miles an hour, you're not going to need boost. And so that's when this valve will open. So basically, there's a vacuum solenoid. It's not like a solenoid; it's more of a vacuum actuator. That when it sees vacuum, it will open. You know, and this butterfly valve in there opens up, and that's basically allowing air that's coming into the supercharger to go right in. Well, it's upside down, so you know, up is down into the engine, right? So I think I want to keep this, but I think I'm going to machine off right about here, and that'll give me a nice large flat surface for me to drill 4 holes and put an elbow on. And I think I want to keep this because when you have your throttle plate partly open and you're not asking for boost, the supercharger is still spinning at a fixed speed and it's still going to try and make a boost. So I think you're going to be putting additional load on the engine because the supercharger is going to be trying to boost, but it doesn't have the air to boost, so it's going to be pulling really, really hard on that partially cracked open throttle plate, and you're going to be creating a lot of vacuum between your throttle body and a supercharger. So when there's a lot of vacuum, this will open, and you'll be able to bypass the supercharger, and I'm thinking that your fuel economy will improve. Now, if I was going to be just doing a pure performance car and I didn't care about fuel economy and drivability, I would just get rid of that, you know, and just have the supercharger itself. But since this is my daily driver, I think I still want this feature. So I think what I'm going to do is have the vacuum line go. I think it's going to go between the supercharger and the throttle body, or it might go between. It might go somewhere on the intake, a vacuum port on the intake. So basically between the heads and the supercharger. I have to think about that for a little bit because your vacuum, I think, will be much higher between the throttle plate and the supercharger than it would be between the supercharger and the heads. But I think I need to do a little bit more thinking about that, but I definitely want to cut this off. So I'm going to disassemble the supercharger. I want to get the pulley off because we're going to be changing pulleys anyway, and then get the screws out of there and put it on a mill and machine it. But let me get this on top of there so you can kind of maybe visualize what I'm thinking here. So there it is. So we would basically have it would be maybe maybe about this tall. Remember, we're going to put about a 1/2-inch plate in there, so it might sit right around this area. The alternator would be under here. That would still clear it, and I just have to figure out the alignment for the belt. Maybe I can reference one of the mounting bolts or thermostat or something like that, and measure carefully somehow, or maybe just even measure from the radiator or something like that, some fixed point to get the proper spacing. But I think it'll look something like that, and yeah, and then this is the PCV valve, but this and this kind of both go to the same area. So when I shorten this section, I can put the PCV valve in that spot. But that's kind of all I have to show you. So I just wanted to do a little update of where I've gotten. So as you can see, I've cut the lower plenum off of the 93 Crown Vic intake. My original plan was to use one of those band saws it's like a drop saw, but the one I have access to was too small to fit this, so I ended up just using a hacksaw. And yeah, took a while, but whatever. It's done. If you have a Sawzall, that'd be easier, but I guess I'm too cheap to go buy one. So I just used the hacksaw, and you can kind of see what I did here. First, I cut each runner, and then I kind of sliced it into three slices. Three slices. So 2 slice, 2 slice, 2, and 2 apparently is what I did. But so now what I'm going to do is put it in a mill, and I'm going to machine all 8 runner hacksaw, because you can see how they're very uneven. Plus I want to machine them pretty much flush. There's no point in having them stick up, the manifold's upside down, so those would be sitting going down into the V of the engine, into the valley of the engine. And my thinking is there's no point in having them anything other than flush, because you're just going to be boosting dead-ended, or the engine's just going to be sucking, from, there's nothing there to draw from. Whereas if the plenum was there, it'd be drawing from here. But now that we're boosting from the top, we don't need that. So I'm gonna put this in the mill just as you see it, and just take maybe a big 2-inch end mill and just machine all these down. Just be careful, I don't want to hit. So we can see all 8. 1, 2, 3, 4, 5, 6, 7, 8, and then here's your crossover for the coolant, which I just nicked a little bit with the bandsaw, but it's okay. It's not damaged or anything. So I'm going to just be careful when I do that. But maybe for that one, I'll leave it a little high, because when I plug these, I'm going to get some aluminum, maybe 1/8 inch aluminum strip, and cut it into pieces and TIG all around each one with the TIG welder. So I'll be able to block all these off, okay, and then don't touch these surfaces, because this is still our good intake surface. And then I'm going to flip it over, and we're standing at the back now, and you can see that from the Ford factory, these little standoffs, 1, 2, 3, 4, 5, 6, 7, 8, these 2 for the alternator. But then this one I'm not sure what it's for, but it looks like the casting was there, but they never machined it. So I bet you what they did at the factory was they probably machined this face when they did the casting, and then they had some sort of jig that they rested here, and then they probably just took a fly cutter and just machined all these little standoffs flush, so or something like that. But so now, because I know that these are all straight, I can let those sit on the mill table, and clamp here and here. Well, actually they'll be like here, clamp to the table there, and then when I get these milled, I'm going to have them be milled below this surface, right? So they'll be probably maybe down here, like we talked about a minute ago. So then when I machine the top, it'll sit on this nice flat, perfectly, machined face. These intake runners won't be in the way. So then I'll be able to. It'll be supported, nice and rigid. On these full faces, and then I'll go in there and just machine out all of this, and then you'll just see a big open pocket, and then I'll have to make the adapter plate for the supercharger. But that's my plan, and I'm going to hopefully get that done. Looks kind of neat with all this taken apart. Here's the part number of it. I don't know. It says Ford Essex. Not sure what that means. And then this says Roger Foxtrot dash Foxtrot Indigo Alpha Echo dash 924 dash 9425 dash Charlie 24 K. What's K? Kilo? Anyway, that's the part number. So what does that mean? F stands for 90. Maybe that's a 1, 91. F1. Maybe this was a 91 casting. Would that make sense? Did they have that 4.6 in 91? I think that's the year it came out. Anyway, just rambling. So here we go. Next time you'll see me hopefully with this all machined. Just a quick update video of kind of where I'm at. So I completed some machining on the intake manifold. I just got back from the machine shop. I spent about 4.5 hours on this. So let's start at the bottom because I guess that was where I started, and plus it's the easier of the two. So I basically last time you saw it. Last time you saw it, I had sawed with a hacksaw all these runners off, just rough cut. And now what I did is I machined them all flush except for this one. And I didn't do this one because this one is kind of integrated with the crossover tube for the coolant. And I didn't really kind of feel like messing with that. Plus, if I machined down, I would have, I don't know, I guess I just didn't feel like fighting with that and trying to TIG weld the plug. So this one's a little taller, and the other ones are all straight. So I'm happy with that. And then I flipped it over, and this is where the alternator two bolts were. And basically what I did is I touched off on the top of the manifold and I went down 1/4 inch. And first I went down 1/2 inch, and I was like, I don't really need to go down that much. Plus I'm going to be removing volume from the runner height, and I didn't really want to choke off the flow. So first I just did a 1/2 inch. So back here, this is the only corner that needs a repair. I'll just take a 1/4 inch little strip of aluminum, and that will bring it up. So I'll just have to weld in a 1/4 inch piece on the bottom, and then on top of the 1/4 inch piece, and then to the plate I'm going to lay in. So this is a 6 inch wide, exactly 6 inches. I use a 2 inch roughing end mill for the whole thing. And first I took a 2 inch pass all the way down the middle, and you can see that all the runners, I had to machine right through it. You know, my goal, remember, you can see the wooden workbench through here. Those will be plugged off with aluminum. So when the blower's on there, when the supercharger's on there, it's just going to be pressurizing this entire cavity. And it's going to go into, 1, 2, 3, 4 cylinders, and then here's your 5, 6, 7, 8. I know it's not the right number, but there's all 8 cylinders right there, So, and I might have to transfer the 2 alternator mounting holes through the plate, which that's no big deal. But that's kind of how it came out. It's not perfect, but it's pretty darn good. I didn't want to go any lower than this because I didn't want to start machining this intake manifold. I wanted to leave it alone. So I'd say there's maybe a 5/10 shoulder there, but maybe what I'll do is remember there's going to be a plate here. So I don't know, maybe if I round out some of these edges, maybe I'll just kind of break the edges so they're not so sharp, just with a file or my Dremel tool or something. But that's kind of where I'm at. And remember, when we flip over the supercharger, so basically what I'm going to do is I couldn't really figure out how to get this directly on here. So what I'm going to do is get a 6 inch wide plate that's about 1 foot long. It's about 1 foot from here to the back. So a 6x12 plate. And basically we're going to TIG all around the OD to seal that plate. But before we weld it in, we have to get some holes. So we're going to put a big rectangular hole for the blower, and then one more hole for the bypass. Okay, and then we're going to do probably just 6 threaded holes. And then we'll weld that plate in. Then we're going to have to make a second plate. Also with the big rectangle and the bypass, as well as the 6 mounting holes, and those are going to have countersunk bolts in them. So we're basically going to bolt that plate to the plate we're going to weld in. And also the second plate will have the bolts for mounting the supercharger to it. So it's basically going to have lower plate 6 threaded holes, upper plate 6 countersunk holes, and then threaded holes for the mount. Is what I'm thinking. So this will basically bolt right on to here when it's done. But that's kind of my plan. That's kind of how far I got. So I'm comfortable and confident with my machining ability, but I am not confident with my aluminum TIG ability. So I think my next step is to just practice TIG welding aluminum. I got to get some blue tungsten, and I got some, what is this, 4043 filler? Yeah, 4043, so I think that should be good. And yeah, that's kind of what I'm going to do next, and stay tuned for more progress on the 4.6 Supercharge swap for cheap. Right now I've got 4 hours of machine time, 2 hours of hacksaw time, and $30 into the manifold, so stay tuned. Okay, just another update video. What I've got going on here is, as you can see, I've taken an 1.5 inch wide, 1/8 inch thick strip of aluminum from Home Depot, and I've cut them into 2 inch to 2¼ inch lengths, and I'm TIGging them in. So you can see I've done these 2 already. This one I'm about to do, and I'm just trying to cover up all these lower plenum holes because we don't need them anymore, and we want those to be sealed, and we don't want any boost to leak through there. So I think I need to turn up the cleaning action a little bit. I just did. This is only my 3rd time in my life TIGging aluminum, so I'm still kind of learning. Plus I'm welding cast to, I think that's, what alloy is that? Here. It says it's, that doesn't even say what it is. It just says aluminum. But I'm using 4043 filler. I'm using blue tungsten. And I'm using this is a gas lens kit. Looks like I need to turn up the gas a little bit. My tungsten is turning blue, so let's do that now. We'll turn up the gas. Where are we at? We're at about, it should be high enough. That's 25. Maybe, and then I'm at 185 amps. We're running no pulse. We're using the pedal. We're on AC, high frequency start, and I'm doing about 100 hertz, and I just turned it up. I was at about 35, and I'm at about 40% positive. So that means that 60% is going negative on the workpiece, and 40% is going positive. So the higher the positive, the more cleaning action you get. Because remember, we're going electrode negative. So here's the torch. That's our electrode in the negative spot, and then we're grounding on positive, which is the same way you'd run steel. Still learning here, but I figured I would maybe just share my setup and what I'm working with. And it seems to be coming out okay. Like I said, this is only my 3rd time in my life TIGging aluminum, but it doesn't need to be pretty, it just needs to work. This is going to be in the bottom of the intake, you're never going to see it. Alright, so I've got 7 of the 8 plugged. I don't want to do this one, because if I put the plate and weld it, it's going to be above this surface. And I don't really want to do that yet because in my welding, the intake manifold warped a little bit. So I want to be able to machine. I'll just take my fly cutter and just fly cut these just enough to get them, you know, nice and straight again. And I don't want to do that until after I take in our plate. But you can see I just took some water and filled each of these pockets, and none of the water leaked out, so I'm pretty sure we got a nice good seal. Here I made a mistake, so whatever, maybe I'll try and polish that down, but it came out okay. And so now I ordered an 8" by 12 plate that I'm going to trim down to 6 inches on the bandsaw, and then I ordered a 10 by 12 for the supercharger. So I'm going to wait for those plates to get in, and I'm going to weld the plate in. And after I weld the plate in, then I'll fly cut it flat, and then I'll use that surface and fly cut these two nice and flat again. So that's kind of my plan. I just ordered the plate, and it should be here probably, I don't know, next week or something like that. So I'm just gonna hang out till then, and just wanted to show you what I've gotten to. I made a mistake here too. I got confused. I thought there was this hole and then there was another hole, and I'm like, well, whatever. It's just you're never going to see that, like I said. And a few of them turned out pretty nice though, so not bad for my first, I guess that's my first real time welding aluminum, but third time welding aluminum in my life. So hang on, I'll give you an update when I have more to show you. Some further progress on the Crown Vic Supercharged project. So I disassembled the supercharger from the 2001 Pontiac Grand Prix, and as you can see, I've cut off the throttle body section because we don't need it, and we're trying to get as much room as we can so that we have some clearance with the firewall, you know, at the back of the engine. So what I did was I set it in a bandsaw, just kind of as you see it, and the bandsaw cut this part off. So here's the bandsaw surface, and then you can see that when I removed the snout, and the two screws, the two rotors, we have a very nice flat milled surface from Eaton. So I stood that up on its edge, just like this, and on the mill vise, and I machined the bandsaw surface down about, maybe 1/4 of an inch, 3/8. Remember, the goal is to save the bypass. I don't want to remove the bypass. I still want the bypass to work. So you can see it's still in there, and I removed the vacuum actuator, but it's still in there. So I don't want to really machine it anymore, because at first I was thinking that I would be able to bolt something to here, and I could put a bolt here and a bolt here, but there's really nothing to bolt the two up here. And this casting is fairly thin. It's only about 3/16 of an inch thick. So I'm not sure what I'm going to do. I'm going to have to come up with a plan. I think I'm going to have to weld. I didn't want to weld, but I think if we take it slow, we shouldn't get any warpage, just a little bit at a time. You know, maybe weld here and then on the other side, and then let it cool, and just nice even heating, and we should be okay. I don't want to warp this housing. So that's kind of what I've got going on with the supercharger housing. I'm going to go in there and deburr all this and make it the edges smooth. The bearings, I took some alcohol and some brake clean, and I wiped out in there a little bit, but you can see the bearings are in there still. I haven't removed them. But I heard that grease is a special grease. I don't know how much I buy that, but we'll see. I'm still going to come up with a plan to remove them. What I heard is you tap this hole and you tap that hole, and you thread in a grease fitting, and you just use your grease gun, and using hydraulics pop those two bearings out, because they are needle bearings, but they have I guess the best way to describe it would be is if you took a a can of soup and just took the top off the soup, it would be a cylinder with a bottom, you know, essentially a soup can, and you'd be pressurizing the soup can out, you know. But that's, you can see how the bearings have a bottom there, as well as the needles. So I might replace those, I might not. I'm still thinking. I think we're still in fabrication mode, not in reassembly mode, so I'm not really going to worry about that yet. The other update I have is that my plates came in. So this is a 6061, half-inch thick, 1 foot long by 10 inches wide. The same thing here, 1 foot long except 8 inches wide. I got the 8-inch because I wanna put this on the bandsaw, and I want to cut 2 inches off. Well, a little bit less than 2 inches, and then I'm going to put it on the mill and machine it. You know, machine that edge nice and flat, flip it over, and then machine this edge down to 6 inches exactly, and then it'll slide right in our 6-inch wide pocket we machined. So that's my next step, I think, is to mill this down to 6 inches, and then get that fitting in here nice. Then get rid of all these sharp corners. There's no sense in having any of these corners here. We can get rid of all that, and then I think it's time to actually start working on the car. I know I haven't shown you the car, but you all know what a Crown Vic looks like, so I think that's going to be my next step. I think I'm going to try and use all the same, well, not the same belt, but all the same pulleys. I only want to run one belt. I don't want to run 2 belts. And this snout will line up pretty much right above the alternator. So I'm hoping I might be able to run an idler down here, so that it'll go around the alternator, around the idler, and back around the supercharger. I hope. If that doesn't work, then we'll have to come up with another solution. But that's kind of where I've gotten to so far. And the parts are outside in the garage. I left them down there. So this, I don't know what I might have to come up with a way to, gonna have to fill that in, you know. So I might fill that in with filler wire and then put it back on the mill and just face it off, you know, just remove 10 thousandths just to get that surface nice and flat. But I figure for planning my next steps, this will be good enough. So I think the next time you see me, I will have machined this to size and maybe come up with more planning for putting it on the car.